Computer. So our topic for today is rationalizing the denominator. So of course, our objective for today is to rationalize the denominator of radical expressions. You'll demonstrate this on the exit ticket, the quiz, and then the unit test at the end. Have a little bit of an overview. We're going to talk about how to rationalize the denominator when there's just a single term on bottom. Then we'll talk about it more when there is two terms. All right, we have a plus in between. 3 plus some square root or square root plus or minus some other square root. We'll talk about that. We've technically already gone over part of this right here, talking about conjugates in a previous lesson, and so we're going to keep talking about it. Then we have our you-do at the bottom. It's a little bit shorter of a you-do than usual because we only really have 2 topics that we're going over. And then we have our exit ticket at the end that we're going to do. Right? Remember to do that exit ticket because that is how the school does attendance. So make sure you complete that by the end of the period if you want to be marked here. All right, so let's go back up to the top where it says we do practice. Let's start in. Rationalizing the denominator. So I included some videos if you want to go watch those as well when you get home and you forget how to do everything, because sometimes you do. I've also included some steps that are kind of more basic steps we can kind of think about. But rationalizing the denominator is really just rewriting the expression with no square root on the bottom or no fraction inside of our square root. So like the problem with example 1 is that we can't have this. There we go. Oh. Square root 2 on bottom. All right, we can't have that square root on bottom. It's one of our rules. The reason we kind of have that rule is because when we sometimes simplify and rationalize the denominator, things actually get more simple. A lot of the times we actually see that the problem actually gets nicer as compared to worse. So that's kind of why we do it, because sometimes it's hard to see that 2 things have something in common unless we rationalize that denominator. Right? The other rule, like I said before, is this one right here. We can't have a fraction inside of our square root. Right? That's not allowed. So we got to break that up and then simplify it. But we will start with the top one right here. Example 1's kind of the easiest one you'll probably see. This is just a starter problem. Our first step is always to simplify the numerator and the denominator. Since 3 and 2 don't have anything in common, we cannot simplify anything, so we're done with that one. Check mark off. Then we go on to number 2. We're going to multiply numerator and denominator by the radical in the denominator to the missing power. We'll talk about the missing power part later on when we talk about cubes, but for now we're just going to talk about squares. Right? So I'm going to multiply this square root 2 on top and bottom. So I do this right here. Right. So I just multiply across. Root 3 times root 2. I multiply since they have the same index. I can multiply them. So 3 times 2 gives me 6, and 2 times 2 gives me 4. And then I simplify. The square root of 4 becomes 2. So remember, that's what I'm trying to do every time with this rationalize the denominator, is I'm trying to get rid of my square root. All right, so now that it's out of the bottom, I've done my job correctly, so I am good. That is my answer. All right. Are there any questions on how I did number 1? The little basic problem where we're just kind of getting introduced to it. All right. Anybody need me to re-go over anything? Talk more about something? Be like, hey, I wasn't paying attention. Can you re-go over that whole thing? Any of that type of stuff. All right, let's go on to example 2 then. I will tell you this, it is always a good idea to try and simplify as much as possible. because when you simplify early, it makes the problem much nicer. It makes the numbers smaller and easier to deal with. Like right now, if we were to do it like regular and multiply before simplifying, we would get 35 times 5, which is 175. Not a very nice number. All right, so we don't really want to do that. So instead, what we're going to do is we're going to see that that 5 and that 35 can simplify a little bit. So I'm going to make it into one fraction bar, 5 over 35, and then I'm going to simplify. 5 and 35 have a common factor of 5, so 5 divided by 5 is 1, and 35 divided by 5 is 7. And so I end up with the square root of 1 over the square root of 7x. Again, I simplified that 5 and that 35. Then I broke it up into 2, and then we'll talk about how to simplify that in a little bit. Now I will say this, I am fine with you skipping from this step to this step without actually writing this part right here. This part right here is the fully correct math way to do it, because you technically cannot divide like that. You can't cancel out things unless it's in the same square root symbol. Right? But we can combine them again because they have the same index. We learned that last time. So since this has an index of 2 and this has an index of 2, I can combine them to be this. Now I'm going to multiply top and bottom by that denominator right there, the square root of 7x. Oh, I did forget a step in there. I also simplified square root of 1 is 1, right? Hopefully that makes sense. Root 7x over root 7x, multiply top and bottom by it, and I end up with root 7x on top, because 1 times anything is just the same thing. And then instead of multiplying these out, what I'm going to write instead is root 7x squared. Now the reason I write it like this is because now I can cancel some stuff out. I can see that this square root right here and this square are opposites of each other, and so they cancel out. So I can go cancel out here, and I'm just left with 7x on bottom. All right, and so that's the process I'm going through. That's why I multiply by the same thing on that bottom part, because when I multiply them together, I get that squared term I want, which is the same as that square root. So the opposites cancel out, and so we have that rational denominator right now. We have that nice 7x instead of the stuff before. Now, before I go through what would happen if you didn't simplify this first, I have another thing I'm going to do right below in case we forgot to simplify. Are there any questions? Any questions on either of these? All right. Maybe the question will come to you as we're working through this next problem. Just stop me and let me know, and I will help you through it. So this is another or statement right here. We could do it this way too. It works, it just becomes a little bit messier of numbers. All right. So instead of simplifying, what I'm going to do is I'm going to just straight multiply top and bottom by that same thing. All right. Square root of 35x. That gives me 175 on top, x over 35x. Now this is where now I have to simplify that top right here, because 175 can be simplified. So we'll have to use our factor tree. 175 is equal to 25 times 7, which can then be broken down even further into 5 times 5. All right. So we have that pair of 5s, and then we have that 7 by itself. And so I can rewrite 175 as 5 squared times 7 times our x still. The reason we do that is because now I can simplify that 5 squared in the square root. Those can now cancel each other out, right? And so I can pull that 5 squared out front and make it into just a regular 5. Now we divide these two. 5 divided by 35 gives us exactly the same answer. So it's the same process. The only difference is that I have to now simplify this numerator a little bit more. Right? It's a little bit harder to simplify 175x than it was to cancel out that 1 and 7. Right? So it's a little bit easier always to try and simplify. Now, sometimes we don't notice how to simplify, or we make a little mistake, and that's fine. We forgot to or something. It still works out in the end. It's just a little bit bigger numbers and a little bit harder. Right? At least harder to meet. Some people like it better. Are there any questions on that second method I showed you where we just multiply right away without trying to simplify first? All right. Then let's do this to make sure that you're all still paying attention. Which way do you like better? The first way I showed or the second way I showed? I'd like you to put your answer in the chat. Do you like the first way or the second way better? You got one for the second way. See if I get some more people telling me. Which one do you like better? 1 and 1 so far, 2 and 2. All right, let's see if I can get some more people. Number 2's, oops, keep it even. Most people like either way. It's kind of equal. Pretty much the exact same. All right, good. Again, it's up to you on which way you want to use. I show both so that you know how to do both, and then you can make your informed decision. Right? Now we'll go on to example 3 now. So there doesn't seem to be any questions. What I'm going to do for example 3 is I'm going to simplify first again. A lot of times that makes it a lot easier. This 5 and this 12, for example. I can simplify this 12 right here by changing it into a 4 times 3. Because 12 can be rewritten as 4 times 3. And then a 4 can be rewritten as 2 times 2. All right, so I got the 2's combined. I got the 3 by itself. So I end up with this right here. Next game type. Now I can simplify some things. Like this x squared right here, since again, the invisible index out front here and the invisible index out front here match, I can pull out that x. You can also pull out this y. You can also square root that 4. So in the end, I end up with x square root 5 over 2y square root 3z. I know that the z's are kind of hard to see sometimes. If you want to change it up, you could also switch it to be a capital Z so you can see it better. I'll do that real quick so everybody can see that. Someone asked me to repeat all that, so I'll do that again. First thing I did is I'm going to simplify these. I can simplify parts of these. Like since this x squared term can be square rooted, I can take the square root of x squared. Let's put it over here. Square root of x squared, and that's just going to give me x. All right, because the squared and the square root cancel out. I'm just left with x in the end. All right, so those cancel. I'm left with this right here. Next type. The 5 can't be square rooted because it's not a square. All right, so there's no nice number, so I leave it as the square root of 5. On the bottom side, after I broke up the 12 using my factor tree, like I did right over here, I made it into a 4 times a 3, and I can square root the 4, right, to get that 2 out front. And then I can also square root that y squared the same way we did before. Because the square root of y squared is just y. Because again, those two cancel out. So we're just left with y in the denominator times the square root of 3z. Right? Now that we have it a lot more simple, all we need to do is multiply top and bottom by this square root on the bottom. So we only have to multiply now by the square root of 3z. So our problem becomes much nicer. Right? Multiply top and bottom by the square root of 3z. 5 times 3 gives me 15. Let's change those z's to be nicer numbers so we can actually see them a little better on the screen. It's so small. Right. 15z on top. And then I rewrite this as square root of 3z again on the bottom. Since we have 2 of them, we have it squared. All right. The square root and the square both cancel out. And so I'm left with on the bottom this right here. And so my final answer is x on the outside times the square root of 15z over 6yz. Okay. Before we move on to example 4, are there any questions on example 3? Anybody confused about any part of this? Anybody need any helpful hints or anything? Anybody need me to repeat anything? Go back over anything? Remember, I don't know if you're confused or if you're not able to do it unless you tell me. If you're completely lost, that's a good thing to tell me so that I know to go back over it. So you got lost halfway. So did you understand up to here? Did you understand how we got to this part right here? Did you understand why we multiplied top and bottom by the square root of 3z? All right. So we multiply top and bottom by the square root of 3z because we want to multiply top and bottom by that bottom square root. The reason we do that is because when we multiply them together, we end up with something squared. So when we get that something squared, the square root and the square cancel out, which is the whole reason we're trying to do this of rationalize the denominator, getting rid of the square root in the denominator. Right? And so those are going to cancel out. And so we end up with a nice no square rooted denominator, 6yz. So that's why we choose the square root of 3z on top and bottom. Because when we multiply them, we get that squared. The square and the square root cancel out. So we're much easier off that way. Does that make sense? Or do you want me to explain it some more? Anybody else need me to explain anything else? Like maybe earlier on or anything else? Or maybe you're like, hey, I figured out some question that I have for example 1. Can you go back up to that one and maybe talk about it? All right. Doesn't seem to be, so we will move on. We do only have so much time today, so let's keep moving. Let's move on to example 4 now. Example 4 is a little different. Who can tell me why example 4 is different than any of the examples we've done so far? You can put it in the chat or unmute themselves and tell me. What's different? It's one correct answer. See if I can get anybody else to tell me the correct answer. Perfect. I love all those answers. Someone said it because it's a cube root. Someone else said because there's an index, because there's a 3 instead of a 2, all those type of things. All right. So because there's a 3, it's going to be a little bit different now. We're going to have a little bit different of a problem. We're going to start it the same way, though, trying to simplify. Since they have the same index, I can cancel them out. So I can get 10 over 7, because 50 divided by 35. 50 have a common factor of 5, so 10. Divide this by 5, and I get 7. All right? 10 over 7. Then what I do is I break it back apart like we did before when we were simplifying this one up here. Break it back apart. And now we need to multiply by that missing index. This is where the missing power part comes in. Because if I just multiply this by the cube root, that's not a very good cube root. If I multiply top and bottom by the cube root of 7 and the cube root of 7, I will only get, I'll get the cube root of 70 on top over the cube root of 7 squared. Now the problem with that is that my indexes don't match. My index and my power don't match. This 3 and the 2 don't match. So instead of just this, I need to actually put this to the second power right here, and the second power. The reason I do that is because now when I multiply them together, I add my exponents. 1 plus 2 now gives me the 3 I needed. So now my index and my exponent match, and so they'll cancel out. Now that's written for you. That'll change the top right here too. Let's clear this off and actually show it properly so that it looks nice. Multiply top and bottom by that cube root of 7 squared, like I said before, so that they end up with that same exponent as their index out front. So now I can cancel them out. I think that I have the answer right here. Yes, I do. Cube root of 490 over 7. Are there any questions about example 4 before I show you another way you can kind of go about this? Another way you can think about this. Any questions? Anybody want me to repeat anything? Anybody want me to go back over anything? Like, how'd you know to make it a squared? I'm so confused on that. All right, one last thing about this one, that if you notice how we did this one right here, if you had not, so the squared number in the denominator got added with this 1 that's invisible right there. Because there's a cube root of 7 has an invisible 1 as an exponent. And so 1 plus 2 gives me 3. So that's how it got to be the 3. Someone asked a great question. Someone asked, can we just multiply it by the square root of 49? That would work as well. I just want you to know that square root of 49 is the same as it shouldn't be the square root, it should be the cube root. The cube root of 7 squared. All right. Those two things are the same thing. I show it this way so that we can kind of see that the cube and the cube cancel out. Right. I also show it this way because it won't always be a 7 in the denominator. Sometimes it'll be an x. Sometimes it'll be a y, stuff like that. And so if we always just expect it to be 7s, then it's going to look a little bit different all of a sudden. Or if we expect it to be a regular number. X's and Y's can kind of change things, where it's going to look more like this every time. That's why I chose to do it as 7 squared. But if you would like to do it as 49 instead, completely valid. Right? Now I want to repeat something. If you had not simplified this right here, you would have been multiplying top and bottom by the cube root of 35 squared. 35 squared is a very big number, and it's not a very nice number to simplify. All right. So I will say this, whenever you get cubes or anything of higher power than squareds, then I would definitely make sure that I simplify first. So if you don't, it gets to be a really messy problem really quickly. All right. Last part, example 4 down below. There's my or statement. I can actually rewrite these as fractional powers, because remember we learned last time that we can rewrite cube roots and stuff as a fraction over their index in the exponent. So the cube root of 10 can be rewritten as the cube as 1/3, 10 to the 1/3 power. And then what I can kind of think about it as is I'm multiplying it by whatever power adds up to be 1. So 1/3 plus 2/3 gives me that 1 I want, that exponent of 1 down below. All right, so that's another way we can think about this. Combine those, we get 10 times 7 squared over the cube, which then simplifies down to be, I think that I actually have it down here. Yes. Cube root of 490 over 7. All right. Are there any questions on that second example of how I showed it? That or statement where I could do it that other way? Any questions on that? Anybody fully lost? Want me to re-explain anything? Anybody? Anything? Right. Let's make sure everybody's paying attention again. Which way do you like better? Do you like option 1 above, where we leave it as cube roots, keep it as rational expressions, or option 2, where we change it into a fraction? Right. Which one do you like better, option 1 or option 2? Currently split 1 and 1 for each. All right, option 1's taken over. It's got 3 new ones, 4, 5. Good. Option 1 seems to be what most people like. That's fine either way. If you like it the other way, you're fine. All right, sounds good. We're going to move on now. We just finished up example 4. We're going to move on to the next thing is where we have the conjugates. With the conjugates, we're going to use the opposites because of the fact that when we multiply these two together, when we FOIL it out, the middle terms will cancel out. All right, so those will always cancel out when I do it. Same things, but opposite signs. We see that in our difference of two squares property. Right? We learned in all the way back in, I think, unit 3. All right. So I can cancel those out. Square root of BA minus square root of BA cancel out. And so I end up with a nice number minus a nice number. No more square roots. If I had tried to multiply this one by just the square root of 6 on top and bottom, square root of 6 over the square root of 6, I end up with 4x root 6 on top. And then on bottom, I'm still left with a square root. I get 3 root 6 plus 6. So that doesn't work. That doesn't rationalize our denominator. That doesn't get rid of all the square roots in the denominator. So instead, I multiply top and bottom by the opposite sign, the 3 minus the square root of 6. Right? Do it to one, do it to the other. I rewrote it right here, make it look nicer so that it was all in one line on each. And then I FOILed it out. 4x times 3 gives me 12x. 4x times this negative square root 6 gives me negative 4 root 6x. Distribute, 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 and I end up with, I don't want everything. There we go. This right here. All right. Do some more simplifying, and I end up with 9 minus 6 on the denominator, which then gives me 3 in the end. Now my last step is always to try and see if I can simplify. 12 goes into 3, but 4 doesn't go into 3. And so we can't simplify this really any further. So this would be our answer. Right. Now, this is a little cheat code that I'm going to give you. And it's that this formula right here works every time. Right. So what I could have done is after I got to this part right here, I could have rewritten this right here without doing any extra math as 3 squared minus 6, which is equal to 9 minus 6, which is 3. Right? This formula right here will always work if it's some number plus or minus some square root. And so you'll end up with 3. And so I could have actually skipped this denominator right here altogether and this denominator right here altogether and just wrote it as 3 on each one of these. Right? Skip that math. Because of the fact that our A's and B's don't actually matter in any case. They can be whatever number we want them to be. And that happens because the middle term, how we set this up, always cancels out. All right? So my denominator will always end up being that same thing because this will always cancel out. The square root and this squared will always cancel out over here on that B, and so you'll always get A squared minus B. 3 being your A. And square root of 6 being your B. And it will work for any numbers that are of this form. All right, as long as you're multiplying the same numbers with a plus and a minus sign in between. Any numbers possible. They'll always follow this formula right here, A squared minus B. Similarly, over here, whenever you have the square root on both of these and you FOIL it out, the middles are going to cancel again, and you're just left with the square root of A squared, which is A, minus the square root of B squared, which is B, and so you'll always end up with A minus B. All right? And so that'll be the formula that you'll get every time. Right here. Excuse me. Before we move over to this one over here and use that formula to kind of help us along, are there any questions over here? Any questions on our example 1 before we move on to example 2 of conjugates? Now I'll give one warning, is that notice how I said you have to get to this point first. A lot of people will try and use this trick and just rewrite the denominator as 3 without having written the numerator properly. All right, make sure that you're multiplying top and bottom by that missing part, rewriting, and then you can use that trick of finding the denominator being 3. Right? make sure you write out all of these steps first, because I've seen in my last 3 classes that I've taught, a lot of people get that wrong in the numerator. They got the denominator right, they got the right subtraction and everything. They got the numerator wrong. Right? So make sure you're doing that. All right. Any last questions before we move on to example 2? Anybody need me to repeat anything, go back over anything at all? All right, we'll do number 2 then. Let's do a quick little thinking right here. If we use this formula, it'll be 5. I don't want to draw that. 5 minus 2, which means my denominator should be 3 in the end. All right. Now on this one, I did show out how to do all of it regularly. Multiply top and bottom by that. Rewrite it again like we did before. And then I distributed it regularly. So that's not going to work. Do it like this. All right. Distribute, 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 distribute. 2 times 5 gives us 10. 2 times 2 gives us 4. All right. Then I did some more simplifying. 5 minus 2 gave me 3, like so. And then my final answer of dividing both by 3, and I get root 10 plus 2. Right. But again, I want to repeat. This is the long way to do it. If you would like to use the cheat code that I gave you up here, the a minus b, once I've written this, I can skip all of this math down here and all of this math down here and just write it as 3 right away. 3 right away. All right. As you can see, it did work for this one as well. Here. Now I want to go back to one real quick thing before I ask for questions, in that this is what I was talking about with when you rationalize the denominator, sometimes it ends up being a much nicer problem. Like who would have thought that this right here would simplify to be square root of 10 plus 2, a much nicer set of numbers as compared to other things. All right. So that's kind of what we're talking about. That difference right there of being able to simplify can really give us some nice numbers. Are there any questions on example 2 before I set you free to do the you do problems in the exit ticket? All right. I'm gonna give about another 10 seconds to ask any questions, and then we're gonna move on. All right, I would like you to start the you do problems. Work on those. Once you're done with the you do problems, you can start on the exit ticket. That's about it. I'm gonna, I'll be here to help you. If you have any questions, let me know, and good luck.